how many 3-digit number are divisible by 6 in all? See, 3-digit number start with 100 and ends with 999, and we have to calculate numbers 3-digit number divisible by 6. See, we will apply arithmetic progression. Now, in case of arithmetic progression, Tn is equal a plus n minus 1 into d, where Tn is last term, a is first term, n is number of terms, and d is their common difference. If we have to calculate divisible by 6, so every number increase by 6. See, first number would be 102, next would be 108, then 114. See, so in this case every number increases by 6, so d would be 6. So important part is this: if we calculate divisible by 6, so d would be 6. Now first term a would be 102, we have to calculate last term. So how to calculate last term? One method is this: 999 divided by 6 and get remainder, and then subtract this remainder from this number, you will get the last number. But the easiest approach is this. See, 6 is divisible by 2 and 3. 999 number could be 998, 996, 994. Right? We can't go further, because if a number is divisible by 6 from 999, only number can go up to 6 value back. We have to calculate last digit, so we can't go, because we will get number from these 3 numbers. See, 998 is not 8 and 6 and 4, all number divisible by 2, and we need to calculate number divisible by 3. This is not possible, this is possible, this is not possible. So last number is 996. Right? So Tn is equal 996, d is 6, Tn is equal a plus n minus 1 into d, d is 6. 996 is equal 102 plus, this is 498 upon 6 is equal n minus 1. This is 6, 1, 4, 9 is equal n minus 1. So number of terms would be 150. Answer is B option. Okay, once you command this method, all these steps can be done in one line, single line. You no need to write like this. Now, how to solve this question in very quick time? See, how many 3-digit number are divisible by 6? So you get an idea that it will start with 100 and end with 999. First term would be 102 and last term would be 996. You can mentally calculate this. We will discuss some methods in further classes so that you can calculate this number very easy. It would be 4, 9 and 8. See, this is Tn and this is A. We have formula Tn is equal A plus n minus 1 of d. We will take A this side, Tn minus A upon d is equal n minus 1, or we'll write n as Tn minus A upon d plus 1. So the method would be last term minus first term, their difference upon divisible by plus 1. Right? So 894 by 6 plus 1. This is what our answer. So in this question it is important to calculate last term. Now one more example. 100 to 500 divisible by 6. So we will calculate first of all last digit, because after 100, 102 is divisible by 6. Now 500, next number would be 498. Now we can't take 499 because we have to check divisible by 6. For that we need to check for 2 and 3. Now for 2 this would not be possible. 498, 496, 494, and because we are checking for divisible by 6, we will not go further by this number. Now this number, yes, divisible by 6, so this is the last digit. Right? Last number. Next question. Question number 7. Find numbers of number from 100 to 200 not divisible by 2, 3 or 5. That question is very important because we have to calculate 2, 3 or 5. Means we have to check those numbers which are divisible by 2, which are divisible by 3, which are divisible by 5. And there may be some number which are common in 2 and 3, which are common in 2, 3 and 5, which are common in 2 and 5, and which are common in 2, 3 as well as 5. For that, Sure shot method is Venn diagram. We will make Venn diagram for three numbers 2, 3 and 5. Now this middle portion shows those numbers which are divisible by 2, 3 and 5. This portion shows the number which are divisible by 2 and 3. This portion shows number which are divisible by 3 and 5 only. And this portion shows the number which are divisible by 2 and 5 only. And this portion shows the number which are divisible by only 2. This portion only 3. And this portion only 5. And remaining portion not divisible by this portion, not divisible by 2, 3 or 5. So how to calculate? See, in this case calculation would be lengthy, and as we discussed in the previous question, what we can do, first of all we will start with the maximum divisibility 2, 3 and 5. So 2, 3 and 5, we will take LCM of these numbers. This is 30, and which we have to calculate numbers from we have from, it means we have to check 100 to 200. So from 100 to 200 total number would be 200 minus 100, first number last number, this is 100 divided by 1 plus 1, total number 101. So this entire diagram, Venn diagram, shows 101 numbers starting with divisibility by 30. See, we have 120, 150 and 180. So there are 3 numbers. So this portion is 3. Right? Now we will check 2 and 3 divisibility by 6. Last number would be 198. See, 200, 199, 198, 197, 196, 195. See, this is not divisible by 2, this is divisible by 2 as well as 3. So this is what our number. See, you have to be very sharp calculating last number. 200 divided by 2 but not by 3. This number divided by both 2 and 3. So this is divided by 6. 190. First number would be 102. 6, 9 divided by 6 plus 1. 16 plus 1. 17 number are there which are divided by 6. Now we have already written 3 here. So remaining value would be, see, divisibility by 6, there are 17 number. We have already written numbers. See, in case of divisibility by 30, we have 120. 120 also divisible by 6, 150 divisible by 6 and 180 divisible by 6. So this 3 number included in this. So we'll write 14 here. That part is very important. See, divisible by 6 are 17 number. 3 we have already written. So we'll write here 14 only. Now we will check divisibility by 3 and 15 or 5. So we will check divisibility by 15. Last number 195, first number 105, difference 90 divided by 15 plus 1, this would be 7 number. So we have already written 3. So here we have 4 values. Now we will check divisibility by 10. 2 and 5, 10. Now last number would be 200, first number would be 100, their difference is 100 divided by 10 plus 1, it is 11. 3 is here, so we'll write 8 here. Now we have filled all the common value. Now divisible by 2, there are 200 first number, last number 100, difference 100 divided by 2 plus 1, it is 51. Now 51, this is for 25, so remaining here would be 26. Divisible by 3. See, last number would be 198, first number would be 102, difference 96 divided by 3 plus 1, this is 33. Now this is 14, 7, 21, 12 number are there. Now divisibility by 5. Last number 200, first number 100, their difference is 100 divided by 5 plus 1. 21 number are there. This is 15 and 21. 6 number are there. Okay. Now these are the number which are divisible by 2, 3 or 5. Now add all these number. 26 plus 14 plus 11 plus 10 plus 12. There are 73 number from 100 to 200 divisible by 2, 3 and or 5, and we have to calculate not divisible by, and total number are 101. So our answer would be 101 minus 73, and this is 28. So answer is D option. That question is very important. Practice this method, and once you command this, you will calculate these value very fast. Right? Next question. Which of the following numbers should be added to 11158 to make it exactly divisible by 77? Right? See, 77 is 7 into 11. No. First of all, we will check divisibility by 11. See, we have to calculate which of the following numbers should be added. We added x to this number. It would be 11158 plus x. Now for divisibility of 11, we will do like this: 1 1 this and 1 5. Sum is 10 plus x and 6. Their difference, x plus 4 should be 0 or 11 or 22 and so on. So x, if we take 0, x plus 4 would be 0, x would be minus 4, not possible. If we take x plus 4 as 11, x would be 7. 7 is also there in the option. Now if we add 7 to this number will become 1158 plus 7. This is 56111. Now we will check divisibility by 7. Now the 7 divisibility is triplet: 165 minus 11, 451. Now this number divisible by 7 as well. So answer is C option. Okay. Next question. Which of the following number is exactly divisible by all prime number between 1 to 17? That question is very easy and important also. 1 and 17. See, between 1 and 17 prime number are 2, 3, 5, 7, 11, 13, and we can't take 17 because it is between. See, which of the following number is exactly divisible by all prime numbers? See, this is 3, it is not divisible by 2. This is not divisible by 2. So we have remaining with 2 number B and D. Now divisibility by 3. This is not divisible by 3. So no need to check further. Answer is D option. Okay. Next question. The positive integer which is nearest to 1000 and divisible by 2, 3, 4, 5 and 6. That question is very important. See, this we have to check divisibility by 2, 3, 4, 5 and 6. This number is not divisible by 4, so cancel this. This number divisible by 2, 3, 4, 5 and 6. Okay, this is possible. 1040. This is not divisible by 3 because their digit sum is 5. So this is not divisible by 3. This is divisible by 2, 3, 4, 5 and 6. And this is closer. Both A and C is possible, but we have to calculate positive integer which is nearest to 1000. Possible answer is A option. Okay, next question. If a number 774958A96B is divisible by 8 and 9, the respective value of A and B will be. Now friend, important part is this: for divisibility of 8, it affects only last 3 digits. So first of all we will calculate B. 96B, 8 1 ja 8, 16, 8 2 ja 16. Now B could be 0 or 8. In these conditions this number divisible by 8. So value of B would be 0 and 8. Now for divisibility by 9 we will add all these digits and then we will check divisibility by 9. So what we'll do, we will cancel 9, 5, 4, 9, we will cancel 9, 6, 8, 14 and 14, 14, 28. So sum is 28 plus A plus B. Now when B is 0, sum would be 28 plus A, and when B is 8, sum would be 36 plus A. Now in this case, A would be next value divisible by 9 would be 36. A would be 8. In this case, A would be 0 or 9. So value of A and B, 8 then B 0. See 8 and 0. When A is 0, B would be 8. When A 9, B would be 8. So we have 7, 8 not possible, 8, 10 not possible, 5 and 8. So only possibility is D option, none of these. Okay. Okay. Next question. That is very important question. A 1000-digit number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It containing 1000 digit when divided by 8. Remainder is. See. A student will misinterpret this question as 1000, 999, but the question is 1000 digit. We will count like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and we will count till 1000. So large digit would not be this. So we have to calculate what would be the large digit. See, 1, 2, 3, 4, 5 up to so on 7, 8, 9, then 10, 11, 12. See, we have to divide 1000 digit. We have to calculate 1000 number of digit. So single digit 9, and there would be 92 digit number, and that is very important that there are total 92 digit number and every digit containing 2 digit. So there would be 180 digit. Means if we write 1, 2, 3, 4 up to so on 99, we will write total of 189 digit. 180 digit this and 9 digit this, and then total 3 digit number are 900. If we multiply this by 900, this would be 2700, and we have to calculate 1000 digit. So this will not go beyond 3 digit number. It means we will not calculate entire values of this. What we'll do, we will subtract 1000 minus 189, because 189 digit used in 9 digit and 2 digit number. So remaining would be 811. So 811 digit from 3 digit number, and that calculation is very important. What we'll do, we will divide 811 by 3. 3 2 ja 6, 21, 3 7 ja 21, remaining 1, 3 0 ja 0, 1. So we can say there are 270 complete 3 digit number, one digit from next number. It means first of all we will calculate 270th 3 digit number. We will use same formula, Tn is equal A plus n minus 1 into D. Tn we have to calculate. First digit, a 3 digit number, first number is 100, or n minus 1, 270 digit number, and difference is 1, because after 101 we will get 101, 102, 103 and so on. So it is 100 plus 269 or 369. So question would be like this: 1, 2, 3, 4, 5, so on, 368, 369. Next digit would be 370, and we have to take only one digit from the next number, right? So this what would be our 1000 digit number. and we have to divide it by 8. So we will check only last 3 digit. 693 when divided by 8, this is 64, 48, remainder would be 5. Answer is B option. Okay, we will discuss some more question on this concept